Thank you very much for the introduction. Since I have 20 minutes, so I will talk about one of the work that's happening in my team. And as the presenter, the MC said, I am from Blockchain at X Research Center, and we are looking for the 2-year postdoc position in blockchain and DeFi, in economic or in computer science. So just please contact my boss, Julian Pratt, in this email. Okay, so today I will talk about the contagion risk in financial network. So starting in 2008, right? So we have big subprime crisis happening in US, and then we have the debt crisis happen in the European countries. Yeah, and during this time there is the rise of the interest in among the network science communities, among the finance and economic, on why such the shock propagate, okay, and just such a small shock, like for example, when Greece say that they cannot pay the debt, then every country in Europe just start to be, let's say, worry about like, okay, what will happen next, okay. That is because this network effect, okay, so people may heard about butterfly effect, right, about the contagion, like the epidemic, like COVID-19, right. So in this thing, in financial network, it can start from, for example, like in this network, Greeks bankrupt, so they cannot pay the debt, then it affects France, and then with this interconnected system, in the end, this risk will propagate throughout the entire financial system, okay? So financial institution is interconnected network, and then you can find the relationship like, okay, Greece owe the money to France, France owes some money to Germany, and vice versa, and then the collapse of one country can just propagate this shock to the network. So it's the phenomena is called too connected to fail. So in the, our research question, because we work on the decentralized finance domain, so we want to try to analyze if this kind of systemic risk can happen in decentralized finance, and how can we evaluate this. So if you are not familiar with the lending and borrowing protocol, so we use Compound V2 as our example. So in this system, we have lender who just deposit your token, right? And then you get C token as the guarantee of your deposit. And in decentralized finance, in DeFi, if you are a borrower, you first need to over-collateralize your asset with some token, and then you can borrow, right? So this is how the things, if everything is like go on right, like for example, like Ethereum price just and Bitcoin prices go up forever, then everything is fine, except when there is the shock, you know, like for example, the price of Ethereum dropped 20%, and at that point, someone will get liquidated because their help ratio just reached the threshold. And what they do to make this system continue is that you will have a liquidator, and mostly the bot, right, that try to liquidate you. So they see your collateral plus some let's say, premium. That is the incentive for liquidator to try to look for the liquidate account and then try to liquidate as soon as possible. And then this is a story on how things gonna happen. And usually when people monitor about what happened in the decentralized lending protocol, you can look at the utilization, right? And then you look at the interest rate, because the interest rate is derived from the utilization. But that is not a part of the full story, because now you know only one side, right? On the asset side, you know how much money have been loaned and how much money you have left as a cash flow in this lending pool. Right? So what we do in this work is that we try to model the balance sheet of lending pools. So you have two parts, right? You have asset, and then you have a liability. And usually the liability is that people deposit the tokens, right? Some people will do it just for pure deposit, and some people just use it as a collateral to borrow the other asset. So for example, like the guy just deposit Ethereum to borrow stablecoin like USDC, and in this case we can find the link, right, between the collateral assets Ethereum and USDC. So this is how lending pools are connected. And this one we can, because in blockchain we have like the granular data, okay, but somehow we use the graph to collect the data, and somehow the data is very noisy, there is some error, so we spend a lot of time to fix that. And then we can try to monitor the balance sheet over time. So this is for one snapshot day. So you can see that there is a Ethereum pool that is big and followed by DAI and USDC. And on the other perspective, because we can find the link between each lending pool, right? So for example, in this case, Ethereum has been used a lot to borrow USDC and to borrow CDAI. And you can see that for finance people, it's a bit weird that like you have a USDC or you have DAI, and then you just borrow the other kind of stablecoin, okay? And you also have a lot of self-borrow. And that is because in decentralized lending, in Compound, you issue the COM token, and COM token has some market price. So that's why people just like do some self-borrowing to try to get this token to maximize the profit, right? But actually, you can see that because most people use cryptocurrency asset like Ethereum to borrow stablecoin, and that is in finance, it's called repo issuance. So you can see this kind of link because in the end you have stablecoin to do whatever you want, and you also have the C Ethereum, which have the value equal to the Ethereum, because it's a promise that you can just retrieve this money anytime you want, okay, if they have the money for you, okay? Yes? Why was Tether in this picture? Hester? Yeah, because it's a very small pool, yeah, so, okay, so what will happen? The judgment day, catastrophic day, is that, let's say that in one day, but it's never happened before, like Ethereum price dropped by 50%. So that means that many accounts will got liquidated, right? So what is encoded in the smart contract is that these accounts are up for liquidation. So there is the people who do liquidation, seize the Ethereum. But in this case, what they liquidate is not enough compared to the original amount. So you post the bad loan to the system. And in this case, the pool have negative net worth. And in the financial literature, if the pool have negative net worth, it's going to trigger something called bank run. So if people realize that this, let's say, this pool have negative equity net worth, then everybody will come to the bank and then we try to withdraw the money. And that is when the bank is default, so they are collapsed. Okay, so in our previous work, we try to simulate the liquidation under the price shocking, like 50%, 100%, and see like how many pools that this impact just propagate. Okay, but this is the previous work. So what I'm going to talk about today is about the contagion in the bipartite graph. Because what we do before is that we just consider the interpool network, in which we just project all the users into the pool. But now we want to try to look into the perspective of the user. Okay, and in this case, it can count as a bipartite graph, where on one side you have the user who deposit or who borrow on this lending pools. Okay, so it's like the link of liability between the pools and the user. And in this case, you can see the picture of the network snapshot. So you can see that liquidity pool now are not directly connected, but they are connected through the user. So that means the diffusion of shock just passed to the user. And what we do is that we try to simulate the propagation of shock in this bipartite graph and try to focus on which user is more critical to the system. So this is the empirical analysis. Okay, so we just like select one random day, and then we look at the distribution of user, and you can see that in Compound, most people are just dust users because they just deposit like less than 10 US dollar, and that's because when you try to perform the action in blockchain, in Ethereum, right? Sometimes you have some delay between the time that you intend that your transaction will be included and the time that it actually includes. So we saw a lot of dust user, and you can see that there are in the second chart, in the middle chart, you have the big user, but big user you have the red dot, which means that they're doing mostly self borrow. So in this case, it means that you have a user, then you deposit to the pool, and you also borrow from the pool. So that is the loop effect, okay? So you see that the top one is just a self borrow. And then you can see that if there is the rich people, okay, big depositor or big borrower in such a pool, in the concentration index, yes? Yeah, it's just a wallet. Yeah, so each one is the account. Yeah, it's a wallet. Yeah. So we didn't aggregate or do the clustering yet. Yeah. So the framework that we use for now is that we use a DeFi, which is widely used in the physicists, network science, and this one in this DeFi algorithm, they measure systemic risk because they measure how financial distress. Okay. Distress, okay, it's not just the real amount. It's not the real amount. It's just the distress, okay, propagate across the interconnected entity. So this one is a classic paper. And what we do is that we perform the depth rank simulation on this bipartite graph. So we start from like, let's shocking the Ethereum price to 50%, and then we check who got liquidated under this situation, and then we cascading impact based on this algorithm, and then see which user can propagate a lot of the loss throughout the system. Okay, so what we perform is that we perform the shock size, right, from 10% to 50%, and you can see that if you have a mild price shock for each of the top pool like DAI, ETH, USDC, USDT, and Bitcoin, you see that you have some stress in the system. So the more the shock price, the more intense this depth rank, okay, this financial distress is in the system for the entire network, okay. And you can see that over time, after 23, you can see that depth rank score decrease over time. That is because the pool accumulate the net worth, so they have more equity. But they also have a lot of reduced activity in the user because people after 23, they just move from compound to Aave or to other activity in DeFi. We can also measure the shock amplification because we start from the initial loss from the liquidate user, right? The account that under liquidation. But then when you use this algorithm, you can measure how much stress propagate to the system, and you can see that there is an amplification, not like 2 or 3 times, but 10 or 20 times. Okay, I will mention again that it is not the real number; it's just from the depth rank propagation equation. So we can see how this stress can reach everyone else in the network. Okay, so you can see that even minor liquidation can cascade significantly into the loss, okay, from the depth rank simulation, and the amplification is nonlinear. So you can detect a critical user in this case because you can calculate the loss propagate for each user within the bipartite network, and you can see that the one that I label with the account, they are the larger borrower that propagate a lot, okay, to the entire network, and the top 3 is you can see that they are Yearn Finance, they are Morpho, and they are the account fund by Kraken. So this one propagate loss are margin trading accounts. We can also look into this graph, right? Because you can have a linear loss, right, one-on-one, or you have something like not so linear, and you can see each strategy that each user use. For example, like Morpho, they deposit a lot of Ethereum, but they also play with the other asset just for the self-borrow, and that's why they propagate more compared to the other strategy. So this is what we can find from this simulation. And so what we do in this work is that we try to outline the methodology to model the systemic risk in decentralized lending. We identify that there are 2 main functions of compound. You have repo issuance, you have liquidity mining, and we conduct stress testing on the bipartite graph to access the systemic risk, how it propagates throughout the network. And we can identify the critical user that possibly propagate this throughout the system. Okay, and but there are a lot of things to be done. So we want to try to find the factor, like why this guy has is more systemic risk than the other. Maybe because there is a strategy that they use to invest in decentralized lending, and because the debt rank is the algorithm, right? It's just based on some let's say that there's some loss function, okay, some distress function propagation, but we have a new PhD in applied mathematics and economics who will just do more realistic modeling. Like for example, when the price drop, then the user got liquidation. But if you have big liquidation, it can also reduce the price of the token. So it's more like a feedback loop, right, into this system. And this one will lead to the more realistic simulation of the risk in the DeFi system. So thank you very much for your attention, and I am happy to answer the questions.
Thanks for the speech. Any questions?
What was the decision made to take a look at the compound protocol instead of other protocols? That's basically my question.
Because back then, 3 years ago, Compound is still the leading decentralized lending protocol. And then we start to collect the data by that time. And after 3 years, we realized something. But now we try to extend it to Aave and Morpho. Yeah. But I think Morpho, they use some different systems. So we need to study the paper, the white paper on that.
Okay, clear. Now question would be, coming back to the question that I had with defining the user, using interconnections between different wallets in order to identify like institutions, for example, FTX and etc., and like to, well, basically escalate the research further. Is there a plan where, I know you occurred into...
So right now we consider that each account is independent, right? But we can also rely on the Etherscan label data to group those with the same, let's say the same company together.
Yeah. So is it in the plans or?
Yeah, it's in the plan. Yeah, in the plan. But we have so many plans. But yeah, we will consider this into account too. Yeah.
Other questions? You want me to run now?
Can you return to the slide with the kind of heat maps, please?
Yes.
No, yeah, this one. I was just wondering, why is there such a huge difference between USDC and USDT?
Because in USDT, after Luna collapse, in Compound, the collateralization ratio is 0. So you cannot use USDT as a collateral to borrow anything else in Compound V2.
Okay, so it's basically disabled.
Yeah, so that's why there is no much propagation, because you cannot use this to borrow anything. Yeah.
Other one? Okay, so thanks a lot.
So thank you very much.